This is Oral Rehab Lecture 4, Part 2. Lecture 4 generally deals with the topic of speech acoustics and with the ultimate application of speech acoustics knowledge to the audiogram, giving the viewer of that audiogram, that would be you and me, the ability to look at an audiogram and get a sense of what speech sounds are available to that person with that particular audiometric configuration. This gives us some guidance in terms of what we can anticipate relative to not only the detection of sounds, but ultimately perhaps to an initial sense of what their understanding might be. All right, so in Part 1, toward the end, we talked about the segments of speech, the individual speech sounds. Here in Part 2, we talk about the suprasegmental aspects, which are features and characteristics that occur in really multiple speech sound constructions, so where more than one sound is put together, where there's particularly words, phrases, and sentences. Suprasegmental aspects include basically things that are occurring, changes occurring across time, but we can categorize them as things like intonation, stress, rhythm, and phrasing. We use the acronym DIPS for duration, intonation, prosody, and stress. As an example then for stress, stress in a two-syllable word, one of the syllables typically has some emphasis, which we could refer to as stress. Now, all of these characteristics, by the way, and all phonemes from the segmental aspects can be uniquely described relative to their acoustic characteristics. We'll see this on the next slide, at least some overarching advice to that point on the next slide a little bit. Intonation, for example, would be sort of a rising frequency contour or a declining or falling frequency contour across connected speech. In English, intonation, while it bears some information, obviously, doesn't bear especially purely linguistic information in the sense that the intonation pattern changes the word meaning or changes the phrase meaning. Now, in Chinese and Thai, intonation patterns will in fact change meaning. In English, not so much. We do get information from intonation, but not to the same extent that you might in some languages in which it's information bearing. In general, the DIPS cues, the suprasegmental cues, are found in the frequency range below 1,000 hertz. So that means that if your hearing is pretty good through 1,000 hertz, you would have access to the suprasegmental aspects of speech. So when we think about the structural aspects of speech, the segmental aspects and the suprasegmental aspects, we have to kind of think about what's important in oral rehab. And what I want us to think about in oral rehab interpretation is that we want to kind of fall back to the acoustic representation of whatever it is that we're considering, whether it's a segment or phoneme, or we're thinking about the suprasegmental aspects. And all things in speech can be broken down into their fundamental acoustic representation across three categories: frequency, intensity, also said as amplitude, frequency, amplitude, and duration. It's the unique combination of those three acoustic characteristics, frequency, amplitude, and duration, that are going to determine what individual phoneme it is. Those three characteristics will be the unique descriptors of whatever suprasegmental aspect we're talking about. And so since hearing is fundamentally a sense that gives us frequency information as perhaps its most important contribution, anytime we intersect frequency in any speech sound or in speech in general, frequency takes on a great primacy to us in oral rehabilitation, because when we generally categorize hearing loss, we're thinking about that a person does not hear as well some frequencies. That's why we do the audiogram. The audiogram basically has to do with a measurement as a function of frequency. So frequency information is really important to us in oral rehabilitation. All right, another way to think about speech sounds, and again, more or less just to give us collective vocabulary in common, but words that I'm sure you're used to hearing, are the classes of sound as vowels and consonants. Now, there's many subgroups of consonants, and depending on who your previous instructors were relative to development of speech and language and that sort of stuff, or linguistics, then you're going to have a variety of other possible names here, which I'm not that interested in this point, but we'll refer back to them and maybe refer back to the IPAs on some of these as well. All right, the third category or way to think about speech sounds has to do with features of production of speech sounds. Table 4.2 in your book is a synopsis of some other information from other sources, and these are sort of time-honored sources in which some of the features of speech sounds are considered. The main features are place, manner, and voicing. In reverse order, voicing is just whether or not the larynx is vibrating or not during the production of that sound. Place describes what it says, place, where in the mouth, where in the oral cavity is the major constriction and the major sort of place of location, the location where the major articulator is placed for that particular sound. Manner is sort of how is the sound made. So place is where is it made, manner is how is it made, voicing is just simply is the larynx vibrating during the production of that sound. So when we consider then on this typical table place, you see that in this chart anyway, there's 1, 2, 3, 4, 5, 6, 7 classic places where consonants are produced. So the notion again is that these things generally then refer to consonants. Misspelled consonants. Manner of articulation, so this notion of features has to do with consonantal production. Manner of articulation talks about sort of what's going on, what is this, what are the structures doing physically. So we have this idea of these stops or plosives, in which there's a momentary blockage of the airstream out of the body, and then a release, which is that explosion. So the stop refers to the fact that the energy is halted, is dammed up at some point and then released, and that gives an explosion of energy. The fricatives has to do with a very narrow constriction somewhere in the oral cavity, in which then air is blown over that, causing a turbulence and causing a sort of a noisy sound quality. And affricate is simply a blend of these two. So if you take some a stop and then follow it with a fricative very closely, you have something called an affricate. Nasals are sounds in which the velopharyngeal port is opened, and then air and energy is allowed to resonate and escape through the nasal cavities. And again, all of these sounds above here, and below too for that matter, also can be produced at different locations. Not all places, not all manners of articulation or production are completed at all places in English. What you got to remember is that across the sounds of the world, there's probably about 600 consonants. Now in English, we may use, I don't know, somewhere around 22 to 24 consonants, maybe somewhere in that range. So we don't use all of them, so there's a big set of other combinations of place, manner, and I guess also voicing that are going to determine the rest of this 575 other sounds around the world. Other types of manners, liquids, which a name I don't particularly like, but the L and R sound, and glides. Sometimes you'll see these also referred to as semi-vowels, because these are sort of the W and the Y sound. This is all an IPA, by the way. So these are the IPA representations of these sounds. That these are all, the glides anyway, are shortened vowels, really. All right, so let's think about what's kind of important in terms of hearing loss and speech recognition. As I said to you sort of earlier in this slide set, is that we're really interested in the capacity to process certain frequencies. Hearing loss causes the inability to hear certain frequencies. So if you can't hear at or above 4,000 hertz, that's going to have a very specific impact on your ability to receive, and then ultimately, remember, if you can't receive it, if you can't detect it, it's going to make understanding very difficult. And you won't be able to hear sounds that occur at, in this particular frequency region. So part of what we need to sort of think about and sort of contemplate is what sounds occur in specific frequency regions. So in this particular example, if you can't hear at or above 4,000 hertz, you're going to have the inability to hear the s sound. I'll give you some other guidance in some of these other readings that are available to you. The usual relationship we think about in terms of the generalizations here is that if you have high frequency hearing loss, and for me, high frequency is anything at and above 1,000 hertz, and generally said for this, low frequency would be sort of below 1,000 hertz. So if you have hearing loss at and above 1,000 hertz, it's going to have some problems in your ability to hear some segments of speech, mostly consonants, especially sounds that don't have laryngeal vibration and are those fricative kinds of sounds. Stops also, but sounds like the sound and the sh sound will be difficult for you to hear. If your hearing is relatively good and you have adequate low-frequency residual hearing, the suprasegmentals will be available to you. So your ability to detect the intonational stress kinds of things will be preserved, as would be the detection of vowels and most voiced sounds. All vowel sounds have some energy below 1,000 hertz, or typically they do, and all voice consonants will have some energy below. Now, the ability to receive and understand vowels is going to be based on hearing, above 1,000 hertz on some vowels, but not all. So some vowels will be completely represented below 1,000 hertz, and some not. So in English, the higher frequencies contribute the most to speech understanding. And another way to think about that is that the logic here is that the higher frequencies, those sounds that contribute most to speech understanding, are going to be really mostly the consonant sounds. So another way to say this is that while vowels, so the consonants, the consonants are really what's most contributory to our ability to understand speech. Lower frequencies contribute to detection of speech and to the recognition of suprasegmentals and to a subset of sounds, vowel sounds, that don't give us that much information relative to our ability to understand speech. This particular view is, again, what's called a long-term average speech spectrum. And again, what it's showing us here is in decibels going this way, here's frequency going that way. So this region through here would be the region where there's the most amount of sound. And this is basically a redo, even though it's sort of cited as Miller, from that Fletcher table that I showed you, or the Fletcher graph I showed you in part 1. And so what this is saying is that here's the region where there's the greatest amount of, these frequencies have the greatest amount of energy. And again, the idea is as we go higher in frequency, the amount of energy is going down. So the sounds that are the most important to be able to understand speech are also the weakest sounds in speech. Finally, one little summary table here from material from Nancy Ty Murray. She's an oral rehabilitation author, has a book that we could have used in this class, but we didn't. And it's a very nice table. Actually, I'm just noticing here that she's really has appropriated it herself from another well-known oral rehabilitation author, Carol Flexer. These kinds of materials are useful because it kind of gives us, in those gross audiometric categories, what we could expect to hear or not in terms of how does hearing loss in general affect a person's individual to recognize and understand words. And so again, from a general point of view, this is useful information. Okay, we're going to come back to part 3 then to finish up this sort of general discussion, but now we're going to look at specific phonemes and where we can place those on the audiogram.